This is Clinton P. with another tutorial on differential equations. And this series is a series of questions from the mid-practice problems for Math 304 at the University of Iberia, which we call differential equations. And this is question number 15. 17 questions, and we are done with 14 of them. 15 says, if the solution of the differential equation 1 over sine inverse of x multiplied by dy by dx equal 1 is, if the solution of this is equal x sine inverse of x plus L of x plus c, find L of x. Solve this problem by using differentiation. We could also solve it by using integration. So differentiate in the sense that we find dy by dx, and then we try to find the value of L of x by integrating after comparing this and that. But what we have to do here is just simple. We take 1 over sine inverse x dy by dx equal 1. And then we multiply this. So we multiply the entire equation by sine inverse of x. So this goes here. So we have sine inverse of x onto 1 over sine inverse x dy by dx equals to 1. So to do that, this and this are going to cancel out. We're just going to be having dy by dx. We're just going to have dy by dx is equals to this, and this is sine inverse of x. So dy by dx equal to sine inverse. Separate variable right there. So how do we separate the variable? We multiply this side by dx. So we have dy is equal to sine inverse of x dx. Once we've done this, we can integrate both sides. So we have the integral of dy is equal to the integral of sine inverse of x dx. But you know something very important. Remember, we want to find y and compare that with this. That's the essence of the entire stuff. So we know the integral of dy is just y. So y is just equals to the integral of sine inverse of x dx. So we want to integrate that inverse function. To do that, we will have to do something very important. And what is that? We're going to use integration of parts to integrate this. So if you have y is equals to the integral of sine inverse of x dx, you can say let u equals to sine inverse of x, and then dv equals to dx. So u equals this and dv equals to this. If you differentiate, you have du is equals to the derivative of sine inverse of x is 1 over the square root of 1 minus s squared. And then if you integrate dv, you integrate dx. Remember, for integration of parts, we differentiate one side and then we integrate one side. So the integral of dv is just v. Integral of dx is x. So we'll move on to evaluate this. So I'm just going to write the integral of u dv. Integral of u dv is equal to uv minus the integral of v du. This is the integration by parts expression. That's the equation. This is the equation you use for integration of parts. I'm just going to write that. And then once I'm done with that, I'm going to write y is equals to, now this integral is equivalent to the entire thing. So we have uv multiply u and v. U is this, v is this. So sine inverse of x times x is x sine inverse of x. And then we have minus the integral of v du. What is v? V is x. Remember, du, you have to differentiate so you have to get the s there. So du is dx over the square root of 1 minus s squared. That's what we have. So v du, v times this is going to give you this. Now, we kind of don't know directly what is this integral, so we have to use a substitution, or call it u substitution. So we say let u, right here, I'm going to use red marker. Right here we say let u equals to the square root of 1 minus s squared. If we differentiate, we have the u is equals to In fact, we cannot differentiate just like this. So let's square both sides. We have u squared is equal to 1 minus s squared all squared. That's what we do. We square both sides. And then once we are done squaring both sides, we can simplify. Remember, this one is square root. This one is square root. So u squared is equal to 1 minus s squared. Differentiate 2u du is equal to minus 2x dx. The derivative of 1 is 0. The derivative of negative x squared is minus 2x dx. So we can divide this out by 2 and divide it by 2. So what we have? We have u du is equal to minus x dx. Great. So we say we want to evaluate this. So let's move and then evaluate that. So here's what we do. Find L of x. Great. So we have u du to be negative x dx. So let's rewrite this expression. We have y is equal to x sine inverse of x. What happened? We have u du to be negative x dx. But here we have x dx. What is the negative? So take this negative inside. This negative goes inside. We are going to have plus the integral of negative x dx, all divided by the square root of 1 minus s squared. So I'm just rewriting this. I have not done the substitution yet. I'm just rewriting it. So let's go now and do the substitution. So we get y is equals to x sine inverse of x plus the integral of negative s dx is u du. So it's u du all divided by this entire expression. U is the entire expression. So the entire thing is u. So we have y is equals to x sine inverse of x plus, then they are going to cancel out, so you're going to have the integral of du. So y is equals to x sine inverse of x plus, what is the integral of du? It's just u plus c. But what is u? What is u? So we say, but u is the square root of 1 minus s squared. The square root of 1 minus s squared. Great. So what do we have there? We have y is equal to x sine inverse of x plus the square root of 1 minus s squared plus c. That's what we have. Now, that result we just got, we have to compare that result with the actual solution given. So if the solution of this differential equation is this, find L of x. So let's compare. We have y, we have equal x sine inverse of x sine inverse of x plus L of x, the square root of 1 plus 1 minus s squared, and then c. So what is L of x if you do this comparison? Therefore, L of x is the square root. So L of x is this, the square root of 1 minus s squared. Thank you very much for watching, and we hope to see you in question number 16. Good day.